All right, hello everybody. Thank all you guys for coming out today to listen to me and Joe present on Log, Seam, and Waza. If you guys haven't already, please sign in on the link tree. That's basically how we get our funding for this from ASI. So yeah. So a quick little announcement. Thank you to all you guys that came out to Tech Symposium. We had 158 people sign on the interest form, and a lot of people actually came in person to show out and show their interest for the event. So thank you guys for all coming out, and a special thank you to the e-board for having that and kind of like planning all that out for us. So I think a big round of applause is definitely due for them. All right. And here's the agenda. We kind of have a lot of on our agenda, but it's gonna go quick, trust me. So first we're gonna go over kind of like a little bit about me and Joe, and then kind of like a backstory, what are logs, what is a seam, why is a seam? Today's kind of like all about seams, so you guys are gonna get to know a lot about seams, a lot about me and Joe. So who am I? My name is Alex Chacon. I am a second year computer information systems major. I was previously on the Cyberforce team, and I am currently on the NCAE team. I am also a Swintern.
Hello, my name is Joe. I'm a master's student here doing information security. I was also previously on the Cyberforce team and currently on the NCA team. And currently I'm working as the SOC lead for the campus. All right, so a little bit of a backstory of how I got into logs. It was kind of like my first time going to a workshop, and then I think it was Dylan. Dylan was presenting what is it called? Eternal Blue vulnerability. And he was showing us how like a few lines of code could get us into like other people's computers. And sure enough, when I tried it on my computer, I was actually able to also get into the remote computer. And I thought that was really cool. And like, it was actually really eye-opening how simple, like how two simple lines of code pretty much could get you into someone else's computer. But then in the back of my mind, I always kept the thought like, okay, if it's that easy to get into someone's computer, what happens if someone gets into my computer? Like, how do I know they're on my computer? How do I see that? And that's what got me Googling, and that's what led me to the world of logs. So CrowdStrike defines logs as historical record of everything and anything that happens within a system, including events such as transactions, errors, and intrusion. And the data can be transmitted in different ways and can be both structured, semi-structured, and unstructured. But my simple definition of a log is pretty much a file containing data of an event. Yeah, pick either one. So starting with Windows logs, on the, I guess for you guys, left here, you'll see that we have something called Event Viewer. This is where you're able to see all the logs on your Windows computers. The main ones are application security and system. Application being like mainly your Windows local applications. Security being like whenever you have like a login attempt that fails or succeeds, that's where the information will be stored. And then system being like any events that happen on your operating system level. There's actually a lot of logs. There's like, I didn't expand the application and services log, but under there's like, I think Windows Defender is another important one, and PowerShell. And the way we distinguish between different events is through event IDs. And so on the top right there, you're able to see different event IDs, which correlate to the description of the events. And so if you're wondering, like, if you go down here, event 1116 is a Windows Defender log, and it's just so this will pretty much pop up whenever you have malware running on your computer. You'll see like a little notification on the bottom right of your screen saying, "Hey, Defender found this." But then, yeah, like where is it stored? This is actually where it's stored, pretty much. If you go to Event Viewer, go to Applications and Services Logs, and there'll be like a Windows Defender tab for pretty much that. Moving on, Sysmon is another very powerful tool. It's a tool that pretty much extends your logging capabilities. It has a lot of useful information. Like event 3 was it's generated whenever a network connection is made to your computer, and so it will show like the source IP, the destination IP, and destination ports. Event 8 is create remote threads, and in this example here, it's showing that a command shell or command exe is running. And then another like unique one would be like whenever your clipboard changes on your computer. So that would be like event 24. But there's a lot more events event IDs and descriptions on the actual documentation page. These are just like a few examples, but there's really a lot. Going to Linux, Linux has a few logs here. I guess, have you ever done like a sudo command and then you get like that scary message saying that this incident will be reported? Well, that's being logged, and the location of the log is actually in the auth.log log. And so I just highlighted a few commands here just to show that, hey, this is where it's actually being logged. And so you can see when I did sudo cat etc shadow as a non-privileged user, you see in the log that it shows who executed the command and what command that they executed. So yeah, that's pretty useful. And then another useful log, I don't know if it's a log, actually, it might be a protocol. So syslog is a very popular protocol for devices to use to pretty much log their messagings. This is like pretty much just traffic or like data between two devices. And so a lot of devices on the network actually use a syslog. And on the bottom there, you just see, I just did an ls of var log, and this is where pretty much all your Linux logs are generally stored. And then just for completeness, this is where Mac OS logs are generated. I'm not a Mac user, but from my research, this is apparently how you access it. So don't feel left out. And going on, so let's say you're a SOC analyst working in a SOC. SOC is just a security operations center. And let's say your boss asks you to investigate like something that happened on one of your computers, right? So like if they ask you, look at this Windows computer. Well, now we know how to look for events that happened on there. So you just pretty much go to that log, right? But now, what if there's 10 computers? Sure, you may have like a coworker to work with, and maybe you guys can split the work. But then let's say he keeps increasing the numbers and then eventually tells you to investigate everything. Well, we're kind of like, for lack of better word, screwed, right? So when they say log everything, you guys have to also consider that maybe like some of your servers are running like web servers, DNS, MySQL, or like Active Directory, SSH, but not just that, the actual switches themselves have logs. Your router can have logs, and even the firewall has logs. So when they tell you to log everything, it's you can see how big it gets, right? And yeah, that's a sad day. So thankfully, we have something called a SIEM. IBM calls it let's see, it's a security solution that helps organizations recognize and address potential security threats and vulnerabilities before they have a chance to disrupt business operations. My definition of it is it's just a centralized brain where we send all our logs and then we make sense of it. Like that's my simple point. So the general structure of it is we have collectors. So for, I think, Waza, the collectors are called agents, and then Splunk, we call them forwarders. And then for an outstack, we call them file beats. But essentially, they're pretty much this program that you install on your devices, and they will handle all the transferring of the logs to your central brain. And then things to consider is each like company uses different ports to transfer these information, so that's something to consider. But they get stored in these things called buckets usually, or I guess you can call them buckets or indexes. But essentially, we store them in buckets to organize them into different categories. And when they're stored, we can actually do more analysis on them, and like we can add more data. If you don't like how the log looks, you can actually transform how they appear. And on the analyzing stage, you use like a different querying language. Kibana is one of them, OpenSearch, and then I think Splunk uses Custo querying language. But it's essentially just a way for you to, hey, like if your boss asks you, okay, give me all the failed attempts on your pfSense router. So you just write a query asking it to pretty much find all the failed attempts on your device. And then on the organizing part, a lot of these SIEMs have things called dashboards where you guys can organize your data into good looking graphs and pretty much just, yeah, you can pretty much also create automated scripts to run certain queries that you always like running. But yeah, that's the general structure. So why do we use a SIEM? Again, like you saw in the example, it's a way to centralize our data. And this essentially allows us to get a better view of our whole network as a whole. Like, because we're seeing all the logs, we're also able to do real-time threat detection, because like if something happens on one of your devices, an alert would appear, and then the incident response team can pretty much go and react to that alert. It also helps with compliance management. A lot of the government standards requires logging and storing logs, and again, automation, right? I think nowadays they kind of use AI to also help. And with automation, you can automate like creating all these reports and the reports for government standards. And you can also create custom rules to do different types of threat detection.
Thank you, Joe. Oh, thanks, fine. All right, so one thing that I would like to point out is the difference between different SIEMs. So there are next generation SIEMs and traditional SIEMs. So I'd like to think that next generation SIEMs typically do the same thing that traditional SIEMs do, but a lot better and with a lot of automation. So when it comes to data collection and analysis, next generation SIEMs tend to go beyond like typical log aggregation from like endpoints and logs from just like the various applications on those endpoints. Will actually collect data from things like cloud logs, endpoint telemetry, and even on the dashboard, they'll have threat intelligence feeds. If you've ever looked at a traditional SIEM like Splunk, the dashboard can get kind of cluttered, especially if you don't have specific rules to filter out a lot of data. So next generation SIEMs will use AI, machine learning, and UBA, which stands for user behavioral analysis, to kind of get rid of all the useless logs and kind of junk, to kind of make it like more streamlined. And that's where the kind of user experience and interface comes in. So the user experience and interface when it comes to next generation SIEMs is a lot better than traditional SIEMs. Like I said, next generation SIEMs will utilize UBA, machine learning, and AI to get rid of a lot of that junk and kind of make the user experience a lot better. Maybe you don't have very experienced like SOC analysts or SIEM users in your company. A next generation SIEM can kind of help them, like with their incident response or their log aggregation and stuff like that. Threat detection and response, like I said, next generation SIEMs are going to use AI, machine learning, and UVA to detect threats and quarantine them before they get into the system and before they like kind of like wreak havoc on your system. You don't want maybe like you have a worm on your system, it'll contain it before it gets to other parts of your network. So next generation SIEMs will do that, and traditional SIEMs can also do that, but you also need a pretty skilled threat detection engineer to create those rules within that SIEM to pick up those like events. And maybe there's like a 0-day or something that your traditional SIEM isn't going to pick up, but next generation SIEM might. And also when it comes to scalability and flexibility, next generation SIEMs are built with scalability in mind. A lot of them do offer cloud architecture for their SIEMs, whereas traditional SIEMs tend to run on the host hardware. So maybe you're bottlenecked by your host hardware, maybe you don't have very good computers within your company, and you don't have a lot of storage. Next generation SIEMs kind of put that all to the cloud and put those expenses on the cloud provider. It's also called, I think, software as a service, little acronym, I guess. So some different traditional SIEM solutions are Waza, Splunk, and IBM QRadar. Waza is a free and open source SIEM. It's very easy to use and highly customizable. One bad thing about Waza, though, is right out of the box, it's not really that good. All it can really do is detect log on and log off events utilizing the auth log on Windows and Linux environments. But it's very customizable. And if you integrate things like VirusTotal and Suricata, Suricata can act as an intrusion detection system. And let's say if your network is getting pinged, it'll likely pick up, and then maybe you can like block the IP using some like IP rules or something. And then also VirusTotal kind of acts as an EDR, which stands for endpoint detection response, and will quarantine bad things that are going on in your system. So Splunk is also another very popular SIEM solution. It has very powerful data analytics capabilities. If you utilize their search language called SPL, stands for Splunk Search Processing Language, you can get data from many different logs on the system very quickly. But One thing I'll say about Splunk is the dashboard isn't too pretty. Compared to Waza, Waza is like very easy to understand, but Splunk it kind of just throws the logs at you, and there's a lot of stuff for that. But there's also comprehensive use cases. It's not bad for data analytics, or it's pretty good for data analytics, but it's also not bad for security. But a traditional SIEM that is security focused is IBM Q Radar. I'm pretty sure that their SIEM also comes with an EDR, and it also has compliance management. So if you're dealing with regulatory bodies like PCI DSS, HIPAA, or GDPR, then on the dashboard you'll kind of have all of that, and also has horizontal scaling and load balancing. All right, so when it comes to next gen SIEM solutions, CrowdStrike Falcon, Exabeam, and Logarithm are all pretty popular next gen SIEM solutions. Honestly, for the most part, they all pretty much do the same thing. Like if I move the bullet points from Exabeam over to CrowdStrike Falcon, then it'll pretty much like fit in perfectly. They're all gonna have next generation endpoint detection. They all, for the most part, have cloud native architecture, also offering hybrid solutions for on premises architecture. They're all going to have automated incident response, UBA, user-friendly dashboards and interfaces. It kind of just depends on your company's needs and what they figure is best for their company. So from what I just described, it kind of seems like next-gen SIEMs are like so much better than traditional SIEMs. And that kind of is the case, but traditional SIEMs do have their use cases in the context of business and even competition settings. So when it comes to a competition setting, me and Joe are part of a competition team here at Cal Poly Pomona called Cyberforce. It's a fairly new competition that Cal Poly Pomona recently got into, but it kind of has aspects of CPTC and CCDC in it, where you kind of do vulnerability assessment and stuff like that. But specifically focusing on incident response, one of the main things that we were um, scored on during Cyberforce was how well we were able to do incident response and kind of figure out the attack vectors that our red team was doing to us. So they would kind of give us a little hint and be like, hey, something's happening on your PLC machine. Go look at it, go find it. And Waza would be our first point of contact to kind of figure out what was happening on our machines. There was honestly a lot of events that I would not have saw if it wasn't for Waza. And Waza kind of just made everything a lot more faster because they're kind of just throwing incident response things at us one after the other. And it was very hard. And without Waza, we likely wouldn't have done as good as we did. But why did we choose Waza? Like I said, Waza is free and open source, which was one of the requirements of the competition. It's very customizable. Like I said, out of the box, it's not really that good. All I can really do is detect log on and log off events. But if you integrate things like Suricata and VirusTotal, then it can actually be pretty useful and pretty good. It's also very easy to set up and deploy agents with Waza. To set up, you literally just run like 3 Linux commands, and then it'll like easily like populate the dashboard, the server, and the indexer on one machine. And then also to deploy agents, you just go to the dashboard, copy a script, and copy and paste that into command prompt or the Linux terminal, and then you have an agent easily deployed. It's also easy to understand the logs and the alerts that Waza generates. I'll show you here in a second how much easier they are to understand rather than like Splunk, because Splunk is like pretty hard to understand. And also has cloud storage. You get 7 days free, which really helped us in the competition because we wouldn't have had anywhere to store our logs. So here you can see how the alerts in Waza kind of look like. Here on the left, you can see the date and time that the alert was generated. And then kind of towards the middle, you can see what Waza thinks is happening. So if you look at the second and third event on the screen, it both says credential access and lateral movement. And Waza thinks that this is happening because our offlog on our Linux machine generated an alert saying SSHD authentication failed. And basically, there was a bunch of those. So we were able to, screenshot that, send that to our red team, be like, hey, someone's trying to brute force into our machine. They're like, good job, full points. And like I said, Waza out of the box isn't really that good, but Joe actually integrated Virus Total with Waza, so we're able to detect a lot more things. So here you can see that there was a possible pass the hash attack um, on our system, and Waza alerted that and said it might be defense evasion, lateral movement, persistence, prevest, or initial access. So, just looking at this being our first point of contact really made things a lot more streamlined and a lot easier. And without it, like I said, we likely wouldn't have done as good. And then you go to a Splunk dashboard. It's a lot harder to understand, and if you're not very um very well versed with Splunk, then it can be very hard to kind of like triage your events and find out your attack vectors because it kind of just throw a lot of information at you. So yeah, WAS is very easy to understand. Like I said, Waza was very critical to our incident response team. In the competition, we ended up getting 11th place on incident response, and it was pretty much just me and Joe the whole time. So that was pretty good, and Waza was honestly our carry. But yeah, without it, and I think without it, we wouldn't have done as good. And I think if we switched to a harder team solution to use and to understand, we wouldn't have done as good as well. So when I started in cybersecurity, I thought that SOC analysts were the only people within cyber that utilize SIEMs, but there are also a lot of other jobs that utilize SIEMs within cybersecurity. So you have network administrators, compliance analysts, and threat intelligence analysts. They're all going to use SIEMs for their jobs, but within like different contexts. So a compliance analyst is going to collect and analyze security logs to make sure that companies are complying with regulatory bodies such as HIPAA, GDPR, and PCI DSS. Network administrators are going to monitor network traffic, detect anomalies, and identify potential threats. Here you can see that there's some crossover between a SOC analyst and a network administrator. That's just honestly goes to show you how many use cases there are for a SIEM. It's not just for security. Network administrators also can use it. And also threat intelligence analysts are going to use SIEMs. They're going to use it to correlate security events with their threat intelligence feeds. And sometimes those feeds are built into their SIEM and identify patterns and actively defend against emerging threats. So for our workshop, essentially what we're going to have you guys do is set up a Waza master node. Here on the left side, you can see the Waza master node. It's going to have the indexer, server, and dashboard. It's pretty easy to set up, and then you're going to deploy two different agents. You're going to have a Linux agent and a Windows agent. And essentially, we're going to have you guys pen test your environment and see what kind of traffic you can pick up and what alerts you can generate with your pen test and see how that shows up on Waza. And here's some other resources. If you go to bots.splunk.com, they have kind of gamified using Splunk. They kind of have like little CTF challenges and other different challenges to get you familiarized with Splunk. If you want to look at the Waza documentation before the workshop, then you can at that link. I think it's very good to look at that documentation to kind of see how Waza works and how it's all set up. It's cool and all to know like how to set it up, but it's also very important to know how it works and how to set it up, just in case if you run into any like troubleshooting issues, you can go back and look at the documentation and kind of know what's going on. And also, Waza's pretty easy to set up, and if you wanted to try setting up something harder, you can try setting up ElkSAC. ElkSAC is also another powerful SIEM, but it's a lot harder to set up and a lot harder to use. Here's a YouTube link to it. John Hammond, he's pretty cool. He's a very cool cybersecurity YouTuber. And I think I was gonna add a link, but I think Cal Poly Pomona students actually have free training to Splunk, right?
Yeah.
So there's a free training course to Splunk. I think it's somewhere in the Swift Discord. So you guys can check that out and get some free Splunk training, which I think is pretty cool. You don't have to spend money. Free is always good. Even if I was rich, I always get free stuff.
Yeah. Just to explain more of the training, I guess. Yeah, I just recently found out. I guess Cal Poly has like an agreement with Splunk. I think it's called like the Pledge for Good, where they allow educational institutions or just like people not doing it for profit, kind of provide them with free training. And I think that I'll send the link later, but yeah, some of the courses like are like one of them is like just $300. And so I think like it would be good because it's free, right?
Yeah, free is always good. But thank you guys for coming out today. I hope to see you guys at the Friday workshop. Once again, thank you to the board for Tech Symposium. Tech Symposium was really cool. And yeah, thank you for listening to me and Joe yap about SIEMs.